So to solve radical equations of square root, cube root, fourth root, and so on, our first step should always be to get the radical all by itself. And then we will raise each side of the equation to a power that matches the index. So in looking at number 1, we have to get this radical by itself. So we're going to add 6 to both sides, or sorry, subtract 6 from both sides, leaving us with the square root of x minus 4 equals 4. Then we're going to square both sides. When you square both sides, what happens with the radical is the square will cancel out the radical and leave me with just what's underneath. And then 4 squared is 16. Now we have a simple one-step equation to solve. So we'll add 4 to both sides, and we get that x is equal to 20. Now, with these radical equations, we have to be careful because we have extraneous solutions that we get by working the problem out algebraically, yet when we plug them back into the original problem, they don't actually satisfy the original equation. They don't make a true statement. So we always have to check for extraneous solutions, and we do that by plugging it back into the original problem. So square root of 20 minus 4 plus 6. We want to know if that equals 10. So 20 minus 4 gives me 16 plus 6 equals 10. The square root of 16 is 4, and 4 plus 6 does equal 10. So what that tells us is that it satisfies the original problem, so 20 is my answer. For number 2, we have to get the radical alone first, so we will subtract 8 from both sides, giving us negative 1 square root of x plus 12, and the one writing that 1 is optional. And 3 minus 8 is negative 5. Now I wrote the 1 to remind us that we do have to get rid of this negative here by dividing by negative 1 on both sides. So that leaves us with the square root of x plus 12 equals negative 5 divided by negative 1 equals 5. This is a square root, which means the index is 2. So to get rid of it, we'll square both sides. Gets rid of the radical. And so leaves us with x plus 12. And 5 squared is 25. Subtract 12 from both sides. And we have x is equal to 13. Check to see if that's an extraneous solution by plugging 13 back into the original equation. So 8 minus the square root of x, which we're going to say is 13, plus 12 equals 3. 13 plus 12 is 25. And the square root of 25 is 5. 8 minus 5 equals 3. So it works and is not extraneous. So x equals 13 is my answer. Let's look at a couple of more. This time, I have a radical on both sides of the equation. This means that to get rid of it, we're going to square both sides of the equation. And since the radicals are already by themselves on both sides, all it will do is get rid of the radical symbol and leave us with what's underneath. So we'll solve this equation by subtracting 1t from both sides. 2t minus 1t is 1t. minus 7 equals 2. Then we'll add 7 to both sides. And t is equal to 9. Check to see if it's extraneous. Square root of 2 times 9 minus 7 equals the square root of 9 plus 2. 2 times 9 is 18 minus 7, and then square root of 9 plus 2, which is 11. 18 minus 7 is 11, so the square root of 11 equaled the square root of 11. It works and is not extraneous. For number 4 here, we have the option of working it out with a rational exponent or changing that rational exponent to a radical. If you were to change that rational exponent to a radical, remember that the z is the only thing that's raised to this exponent. So it would look something like this. 2 plus 4 square roots, because remember, rational exponents, the top number is the exponent, the bottom number is the index, so square root of z to the first power equals 0. Now I am going to actually work this problem out both ways, and you'll see that they'll become a point where they kind of merge together and become the same thing. The process is the same, it's just whichever way is more comfortable to you. So if you're okay leaving it with rational exponents, that's all right, you can work it out that way. If you prefer to change it over to radical exponent or radical, you're more than welcome to do that as well. So we'll subtract 2 from both sides. And that leaves us with 4z to the 1/2 equals negative 2. Or if you had subtracted 2 from both sides in this form, you would be left with 4 square roots of z equals negative 2. Then we have to divide by 4 on both sides. So z to the 1/2 would equal negative 1/2. Or dividing by 4 on both sides for the other version would leave you with the square root of z equaling negative 1/2. And we know that when it's a square root, the index is 2. So we're going to raise it to the second power. And we also know that rational exponents, the denominator is my index. So we'll raise it to the power of 2. Raise it to whatever your denominator is. When I do that, the denominator will cancel out, or over here, the radical cancels out. And either way, I'm left with z equals negative 1/2 squared gives me positive 1/4. Let's check it, make sure it's not extraneous. So 2 plus 4 times 1/4 to the 1/2 power equals 0. 1/4 to the 1/2 power is 1/2. And 4 times 1/2 is 2. 2 plus 2 is not equal to 0. That means that this is an extraneous solution. So that means that my answer is that there is no solution, because there are no solutions left that actually satisfy the answer. Let's try some cubed roots. Number 5. Again, we can change that over into radical form if that's what you're more comfortable with. And if you did, it would look like this. We'd have the cubed root of x minus 5 minus 4 equals negative 2. So adding 4 to both sides gives you x minus 5 to the 1/3 power equals positive 2. Or if you were using this form, adding 4 to both sides would look like this. cubed root of x minus 5 equals positive 2. We have to raise it to the index, so that means raising this to the third power. Raise this to the index, which means raising it to the third power. It really is just a notation thing, whichever one you're more comfortable with. Cancels out the radical or cancels out the denominator and leaves with x minus 5 equals 2 to the 8th, no matter which way you did it. So we'll add 5 to both sides, and we get that x is 13. Check and see if that's extraneous. So we have 13 minus 5 to the 1/4 power minus, 1/3 power minus 4 equals negative 2. 13 minus 5 is 8 to the 1/3 power minus 4 equals negative 2. 8 to the 1/3 power is 2. 2 minus 4 is negative 2. So it's not extraneous. It satisfies the equation. And 13 is my solution. Number 6, our radical is already alone. So we're going to raise it to the third power because that's the index. That gets rid of my radical and leaves me with 2d plus 2 equals 216. So we'll subtract 2 from both sides. And we'll have 2d equals 214. Divide by 2 on both sides, and d will equal 107. To check to see if that is extraneous, we'll take 107 and put it back into d. 2 times 107 plus 2 equals 6. 107 times 2 gives me 214. 214 plus 2 is 216. And the cubed root of 216 is 6. So it works. It's not extraneous. 107 is my solution. For fourth root problems, where process is going to be the same, we'll get the radical alone first. So we'll subtract 2 from both sides. And we'll have fourth root of 6x plus 1. And then plus 2, equals fourth root of 6x plus 1 equals 5 minus 2, which is 3. Then the index is 4, so we'll raise it to the fourth power. 6x plus 1 is what's left after the radical is canceled, equals 81. Subtract 1 from both sides, and we'll have 6x equals 80. Divide by 6 on both sides, and that comes out to be a decimal, so we want to leave it as a fraction, but reduce it. So 40 over 3. Math, enter twice, changes decimals to fractions and reduces them. So we'll need to check to see if 40/3 is extraneous by plugging it into the original equation. 6 times 40 over 3 plus 1 plus 2, we want to know if that equals 5. So 6 times 40 over 3 gives me 80. copy down the rest of the equation. 80 plus 1 is 81. The fourth root of 81 is 3, and 3 plus 2 is 5. So it works and is not extraneous. Number 8. Again, you can change this into radical form if that makes you more comfortable. So we'll have fourth root because the exponent will be on top, the index is on the bottom, of 3x plus 7 minus 3 equals 1. Either form you use, you'll have to add 3 to both sides. And in the first form, that would give you 3x plus 7 to the 1/4 power equals 4. Or in radical form, adding 3 to both sides would give you the fourth root of 3x plus 7 equaling 4. Again, whichever one you're more comfortable with, you don't have to have both. We'll raise it to the denominator, which is the index. So raising it to the 4th power. That cancels the denominator when it's in rational form, or cancels the radical when it's in radical form. So it'll leave us with 3x plus 7 equals 256. No matter which way you actually write this, so I don't actually need to write the next step here because they end up being the same. So we'll subtract 7 from both sides. And then we'll need to divide by 3 on both sides so that x is equal to 83. Make sure that 83 is not an extraneous solution by plugging it into the original problem. (83 times 3 gives me 249. 249 plus 7 gives me 256. And 256 to the 1/4 power is 4. 4 minus 3 is 1. So that does satisfy, and 83 is not extraneous.